One rate of change that you may not realize that you know a little bit about is acceleration. So acceleration is the rate of change of velocity. That's a rather long-winded way of writing that A is equal to dv by dt. And that means that we can use Newton's second law, F is equal to ma, and rewrite it as F is equal to m dv by dt. And that gives us another entirely different set of differential equations that we can put together. Here's an example where that can be applied. Just stop the video for a moment or two so that you can read thoroughly through all of the question and try to understand what's being required. With problems of this kind, it's always a good idea to draw a diagram. And there is the object and the driving force of 1200 newtons and the resistance force in the opposite direction of 0.4 times v, and I've shown the acceleration in the direction of the driving force. So we can then use F is equal to ma, or as we're going to write it, m dv by dt. And remember that the F on the left-hand side is the resultant force on the object. And in this case, the resultant force is going to be 1200 minus 0.4 v, and that's equal to m. Well, I'm going to substitute the value of 200 because that's known, dv by dt. And we've formed the differential equation that we're going to go on to solve. Stop the video now so that you can get it into a form in which we can integrate to find the general solution. In this case, we'll move the dt over to the left-hand side. We'll keep the 200 and we'll move the 1200 minus 0.4 v across to the right-hand side where it goes into the denominator and the dv stays. And of course, we're going to integrate both sides. It's important to say that when we were moving things, we didn't separate the 1200 from the minus 0.4 v by adding 0.4 v to the right hand side. If you remember from an earlier video, we said that it's got to be moved by multiplication or division, not by addition or subtraction. Well, we're in a position now where we can go ahead and find the general solution. So again, it would be a good opportunity to stop the video and have a go at doing that yourself and see how you get on. Starting with the left-hand side, we would have t plus c. I've put the c, the constant of integration, on the left-hand side because it's the simpler side. And that's going to be equal to 200. And on the bottom, I've got a linear expression in v, so that is going to integrate to the ln of 1200 minus 0.4 v. But because that is a linear expression in v, it's going to be divided by the derivative of that, which is minus 0.4. And that simplifies to t plus c equals minus 500 ln of 1200 minus 0.4 v. Now we're told in the original question that it starts initially from rest. So when t is equal to 0, v is equal to 0, and that will enable us to find c so that we can go on to find our particular solution. So c will be equal to minus 500 ln of 1200, which we can now put together to give us t minus 500 ln 1200 is equal to minus 500 ln of 1200 minus 0.4 v. So we can make t the subject by taking the minus 500 ln 1200 over, so we end up with t is equal to 500 ln 1200 minus 500 ln of 1200 minus 0.4 v. Using our laws of logs, we can combine that to give us t is equal to 500 ln of 1200 over 1200 minus 0.4 v. We're not quite finished here, because in the question we were asked to find v as a function of t, so we've got to rearrange all of this to complete the question. And so we're going to begin by dividing by 500. T over 500 is equal to the ln of 1200 over 1200 minus 0.4 v. And then removing the log, we get e to the t over 500 is equal to 1200 over 1200 minus 0.4 v. And then we can cross multiply to give us, I beg your pardon, I left a 0 out there, 1200 minus 0.4 v is equal to 1200 over e to the t over 500. And then if I take the minus 0.4 v over the other side and then bring the 1200 over e to the t over 500 to the left hand side, I get 1200 minus 1200 e to the minus t over 500 is equal to 0.4 v. And I divide now the left hand side by 0.4, and I take out a common factor, which in this case will be 3000. 1 minus e to the minus t over 500 is equal to v. And we've got it now in the form that was required within the question.